All right. All right, so our bell work today said someone bet that she could find the height of anything just by seeing its shadow. And yeah, I mean, you could theoretically do this. And we will see different applications for different ways using geometry and later trigonometry, where we can use that information to find the height of a building, find the height of a tree, anything that you want. But what we're going to do is we're going to look at another very similar example. So if you look at number 5, it says a girl who's 180 centimeters tall stands 360 centimeters from a lamppost at night. Her shadow from the light is 90 centimeters long. How high is the lamppost?
You mean 160.
Oh, did I say 180? Yeah, 160. I'm sorry. So what we have is, this is one where a diagram is already provided. But this could have been blank. So, imagine the problem looks like this, and you need to think through it just with a blank space right there. But luckily, you do start off with a diagram. And so I'll go ahead and have that diagram pulled back up. So now we can kind of see a little more clearly that these triangles that we've been practicing with our different handouts, they are used frequently in the real world to model certain situations. And in this situation, these lines represent real-world sort of corollaries or real-world connections, I guess. So in here, if you're thinking about that diagram, a 160 centimeter tall girl, which line in this diagram that's provided do you think represents that 160 centimeter tall girl? The shorter line that cuts it, the one that's kind of right through the middle right here. So yeah, we could say this maybe represents 160 centimeters. And that you might find it helpful for yourself, maybe not, but you can actually, illustrate this. You say, okay, so here's this girl. So it's not just a line. This line represents a person standing up. So when we talk about modeling with math, sometimes we're talking about modeling just by converting things into equations, which that is modeling. But this is actually modeling where we're turning, figures into, like, real-world objects into geometric figures, and then working with what we know about geometry in order to solve it. So this is where we're going to tie all this side splitter and similar triangles and angle bisectors back into useful math, not just random problems to solve in a math classroom. Okay, so a 160 centimeter tall girl stands 360 centimeters from a lamppost at night. So where might that 360 centimeters go in the diagram? What do you think?
The flooring, kind of.
Yeah, not the hypotenuse. You're saying where?
The flooring.
Okay, yeah, whatever they're standing on, like the street or the walkway or whatever. Now, is it going to represent this entire distance right here or something else? Just now, okay, so is the shorter distance meaning that one, or the one on the left, or the shorter distance the one on the right? Okay, and so she's 360 centimeters from the lamppost. Where is the lamppost in our diagram? It's the far right. That tall line right here is the lamppost. So I will, actually I'll leave that there. I won't erase anything. But our lamppost is going to be right here. And I'm just going to kind of illustrate this a little bit. All right, so there's your lamppost in our diagram. And the 360 centimeters is the distance she is from that. All right, I will go ahead and tell you on the test, there will be 2 word problems. One of them will be a problem where a model is already provided and you just need to fill it in correctly. One of them will be blank and you need to draw the model yourself, kind of thinking through the problem. And I will give you another hint further. The one that we are currently doing is one that you should probably pay attention to. Hint. All right? Now, and to be fair, these kinds of problems come up a lot. We're going to keep seeing these as we move into trigonometry, like I kind of hinted at earlier. So you will have a lot of problems where stuff like this comes up. All right, but let's focus on this problem again. Now that she's 160 centimeters tall, we've got that. She stands 360 centimeters from a lamppost at night, we've got that. Her shadow from the light is 90 centimeters long. Where does that 90 go? What's that? Yeah, that small part here on the left. We're talking about this is the 90 centimeters that her shadow is being cast by. So if you're just thinking about the shadow itself, there's a bunch of light all nearby, but here's the actual shadow coming from her. So now you can kind of think of that, and of course all you see of the shadow is what's on the ground. But technically the air in between is not being lit up as much either. Okay, so that's our scenario. And now does this look like something you've seen before? Okay, hopefully it does. In fact, all I'm going to do is I'm going to draw this again. I'll draw it to the left because I've got some space over here. And I'm going to get rid of everything except the numbers. So I've got 160, 360, yeah, 360. I keep making sure. Okay. 90. And then we're solving for the height of the lamppost. We didn't put that on there before. So what are we solving for? Which length? That taller vertical component right here. So that I'm calling it H. You can call it X if you want. But now that, if you go back to the worksheets that you've been looking at before, that could be any one of those problems that you've already looked at. Okay. So that's the main skill, the main thing we're looking at today is how to take numbers from a real-world scenario and plug them into a model so that then we can simplify and distill it down into a basic problem that we've already had practice solving. Okay, so looking at this, let's go ahead and just go to the next step of setting up our proportion here. What kind of problem is this? Is this a mid-segment, side splitter, angle bisector, or similar triangles problem? Which one? It's not mid-segment. It would be mid-segment if these two distances were equal, the 90 and the 360. Then we'd know we were looking at a mid-segment, but that's not the case here. Therefore it's similar triangles by deduction here. So similar triangles because, let's look at this simplified diagram. These lines are parallel and we've got the distances along the parallels. So that tells us to do similar triangles, which means, and this is the last little bit that we'll do for this one, I'm going to draw these triangles separately. I know the smaller one is 90 and 160. We've already had practice with this. So what's the bigger triangle? What are we going to have for that? 450 along the bottom, the entire length, and the height is what we don't know. All right, so does that make sense? Okay. And set up our proportion real quick. I'm not going to go through and solve the proportion, but let's just set up the proportion. And what is it? (90 over 160 equals 450 over h). Very good. All right, you guys can solve that. So you can see the hardest part of all of these problems, whether I give you a straight-up diagram or give you a word problem, the hardest part is always going to be right at the beginning. Kind of wrap your head around it, make sure you model it correctly, or choose the correct theorem for it. But from there, once you've got it to the proportion, it kind of gets easier to solve. Okay, any questions on that one? All right, I was going to look at problem number 2 next, but if there are others that we want to look at before I'm done talking today,
So we don't
Aiden.
do cross multiplication, and it's just like
Go ahead, put your stuff up here. All right, so like I was saying, if there are others you want to look through before we're done, we can do that. But I'm going to look at problem number 2 next. Again, the diagram is provided. And it's important to understand what's being asked, okay? So there's a parade committee trying to come up with the next homecoming parade. And we can see where it starts and where it finishes. This diagram is a nice one because it even has the start and the finish marked. And it tells us, just to simplify this, we're going to go south until we get to 20th Street, east on 20th, and then back up Pine Avenue until we get to the finish right here. We need to know the distance of that parade because the committee needs to know how long it's going to take. Okay, so we have this set up, and we're looking for, what is our final answer going to be? No, I'm sorry, not the number, but what is, in just a phrase here, what is the final answer for this problem?
How long it is?
Yeah, how long? The total length of the parade. And I say that because it's really easy to solve for x, solve for y, and just say, here's x, here's y, I'm done. But that's kind of the first step of the problem, and then you need to make sure you're showing the total length of the parade. All right, so how are we going to solve for the total, or how are we going to solve for x and y? Side splitter. Okay, now this is a triangle. I could continue these lines coming down and create a triangle out of it. We don't really need to see that, but it is important maybe to understand that these streets do kind of form a triangle, and we're only interested in the lengths along the sides, not anything along the parallels. And that 750 that's there, we're not using it for calculations until the very end. All right, so tell me, if it's side splitter, we're using proportions. We use proportions for everything except mid-segment. So tell me a proportion that I can use to help solve for some unknowns. Okay, 380 over 500 equals 425 over x. Okay, and remember, pattern of correspondence. These correspond, the 380 and the 425, the 500 and the x correspond to each other. So if we use a pattern of correspondence, 380 over 500, those are the adjacent segments along Beacon, equals 425 over x, those are the adjacent segments on Pine. But we're keeping the order between them the same. So,
But it could be flipped around.
it could, so it could be 500 over 380 equals x over 425. But in this case, we're going bottom over top equals bottom over top. As long as you're consistent with your pattern, you can set it up lots of different ways. And what I want you guys to do is I want you to set up your next proportion to solve for y. And I'm going to have you guys kind of share that in a minute. All right, so let's use that one. I'm going to write, so 380 over 600 equals 425 over x. And that's what we had written down. That was what someone wrote. And you can see it's kind of following the same pattern, but instead of 380 over 500 right here, we're doing 380 over 600 equals 425 over y. I put x, I meant y. Okay. So with these two proportions, you can go through and you can solve for x and y. The way that those are set up, does it make sense? All right. If it's not making sense to you, then that's going to be kind of a sign. You can add little asterisks and stars and circles and stuff around stuff that you still don't understand. But anyways, from here, once you solve for x and y, what's the final thing you need to do? Add up the total length and report back what that total length is. All right, are there any other problems on this worksheet that you wanted us to focus on as a class? Number one. And number one, when you examine it, it's actually not too bad. All right, so Carl's Construction is building a pavilion with A-frame roof at the local park. Carl has constructed 2 triangular frames for the front and back of the roof, similar to what you see in triangle ABC right here. The base of the frame, represented by AC, is 36 feet long. He needs to insert a crossbar connecting the midpoints of A, B, and BC for each frame. He has 32 feet of lumber left after constructing the front and back triangles. Is this enough to construct the crossbar? So let's go ahead and fill in. We got some numbers here. Let's see what numbers we can start filling in. So if we're looking at, I'm sorry, it's not showing up on the screen. If we look at this right here, let's go to that middle. It says the base of each frame represented by AC is 36 feet long. So where are we going to write that? Along AC. Yeah, so I'll just put in the 36 feet. All right, now what kind of situation are we looking at? Is this mid-segment, side splitter, angle bisector, similar term? Mid-segment, okay. So notice that they were saying that the crossbar needs to go connect the midpoints of AB and BC. That means that these are going to be congruent, and those will be congruent, right there. So in this kind of situation, it is mid-segment. The congruency marks aren't there, but you can add them. All right, so if we've got this, what is the length of DE? 18. This is kind of an easier situation where you don't have to set up an equation. You just realize your mid-segment is always half as long. So if 36 is the parallel side, 18 is half of that. So I'll just kind of write this 18 feet bigger for everyone to see it. Is 32 feet enough lumber to get both of those done? No. So really your answer in this case is yes or no. Yes, it is enough lumber. No, it's not. And so your answer here is no, but you had to do some math to get to that point. I guess you could have theoretically, yes, also just built one of them and seen if you had enough to stretch the length for the next one. But now you've mathematically shown that. All right. Any other problems on this one? All right, keep in mind, just try and reduce it down first of all and say, as a geometric diagram, am I looking at a side splitter, angle bisector, similar triangles, or mid-segment problem? All right, so work from there. You have 20 minutes. Let me know if you have questions. I'm going to post an answer key on the Google Classroom later today. So if you want to look at, and it'll be a separate document, so if you want to look at that later over the weekend, your test will be on Tuesday, so make sure you're practicing with all this stuff.